Welcome back to WEGS Garage, where today we have on our 1964 Triumph TR4 yet another alternator project. That's right, everybody. We got another dead alternator, but this time we're gonna fix it a little different. Stay tuned. So this is the alternator setup that we use to replace the stock generator on this car. It's a GM 10SI alternator. They're very common, and also very common for these generator alternator swaps. We purchased this unit. It's a remanufactured one a few years ago. I think they're only like $50 or something like that. And this is actually the second one we've had on here. I don't really know what the deal is, but it just seems like we keep getting bad alternators. And we've tested this thing 10 different ways. We've removed every bit of wiring from the car and bypassed all of it to let this thing charge, and we still get very low output from it with the engine running, only like 12.3 volts or something like that, and it's just not enough to actually keep the battery charged. But first things first, we're gonna get this old alternator out of the car and on the bench where we can take a look at it. All right, so on the bench here we have our three test subjects. This is the original generator off the car. Here is the 10SI alternator that we just took off. And this is our new alternator off of a 1987 Suzuki. So right off the bat, you can see this is the largest of the three. The great thing about this new Suzuki alternator is a couple of things. One is it's much smaller than the old GM alternator. The other is we've got a pair of mounting ears here, which is a little bit more compatible with the way the Triumph generator mounts up, and kind of is, I think, going to help support it a lot better and keep it from bending and all that stuff. The other thing is we used to have to cut a little bit off this back part of the GM alternator and file that down to get everything to fit right, and we shouldn't have to do that with this. It should fit in there really nicely. In fact, it's pretty similar diameter wise to the original generator, so and mounting wise, so it's really going to sit in about the same position. The only thing we got to figure out is how to get everything lined up with these new mounting ears, with various spacers and bolts and things like that, and we're gonna get it installed. So we're gonna figure that out now, and we'll take it from there. All right, so here's the kind of mock-up, what we're doing here. Tried to line up with the old generator so that the mounting ear was in about the place it's going to need to be on the car based on the position of the pulley here. We did that just by propping up with some sticks here to get about the right height. And here is what it kind of looks like. So if we wanted to use this original generator mounting point here, we'll just have to remove about that much of it. So right now it's kind of looking like our best option. If you had the equipment, you could make kind of a custom spacer for that. And then on the back side, you can tell we're way off from that, but we can just put a spacer in here and run a long bolt in and put a nut down on this side. for the back part of the bracket, and then we get our 2 points there. That'll keep everything nice and lined up. Should work pretty good. So we're going to try modifying this original spacer and see if we can't make that work.
A drill bit for a guy your size.
All right, update here. Here's the spacer arrangement we're landing on. Pretty tight spacing here between these two mounting points once we get all this stuff in here. So maybe not quite as ideal as what I had in mind originally, but it should work. We've got the factory spacer up front, shortened a little bit. Shortened a little bit too much, but that's okay. We left room for an extra washer. And then back here will be where that front part of the engine plate goes. And then on the back side, we've got this long bolt with a spacer that's made out of this aluminum tube that's 3/8 ID by, I think, about 1/2 inch OD. Works really good for this. The only thing we did change is we did run a 3/8 drill bit through this back part of the alternator. It has like a little bushing in it, and so it kind of was easy to just make that just a tiny bit bigger so that it would fit a 3/8 bolt, which is more compatible with the bracket on the engine. And then we just kind of eyeballed this spacer cut to fit in the back, and all that's gonna go together really nicely. The only downside to this arrangement is we're gonna have to put this bolt on we're gonna have to take the mounting plate off the engine, put this bolt in there because it won't clear the manifold. And then once that's on there, we can kind of, do a little dance to get all the nuts and everything together. You'll have to slide this bolt back while you put the nut on and all that good stuff. But it should fit really nicely. So we're going to get it fit up and see how it looks. Okay, we're back here, day 2 on our alternator install. We got a little bogged up. We temped up all the wiring last week, and we were having some issues like the warning light was coming on. I think we got a theory on how to fix that. But anyway, we got to kind of finalize the wiring. We've got a special plug to fit this Denso Alternator, and so that we aren't just using terminals. You can find those online. They're not really available in auto parts stores. So we're going to kind of get the wiring finalized. Now, I'm not going to go super detailed here on the wiring for an alternator conversion. We converted ours a couple years ago. There is an old video for that if you want to check that out. What you need to know mainly is there's a few things you have to do. You got to convert to negative ground for sure. You have to decide if you're going to use the factory wiring or not, and you have to decide what you're going to do with the ammeter as far as whether you're still going to run the wire or energy through the ammeter or replace it with a voltmeter or whatever. Those are kind of the main things you need to know to convert to an alternator. There's lots of good guides online. Check those out. That's all I'm going to say about that. So let's get this thing hooked up, and then we'll get her started up. Volts. charging.
Well, sitting here, when the engine gets above about 11 to 1200 RPM, there's no problem. That alternator is feeding about 14.5 volts back into the battery. That's what you want. And if you go above 11, 1200 RPM, it holds at 14.5. I revved this thing all the way up 4,000 RPM, it stayed steady. So, okay, that's not a problem. The problem we were having is that at idle, at 1,000 RPM, the output of that alternator evidently is right on the edge. Now at idle, with no electrics on, just the engine idling, that thing was putting out about 13.8 volts. Well, then you start putting loads on it, the panel lights, the headlights, the heater, the wipers, all that. It'll drop down to about 12.7, 12.8 volts. And then intermittently you get an ignition flickering light on the dash here. I don't think we really have a problem. It's just that when you get at 1,000 RPM or below, you're right on the edge. So I think what we're going to do is set the idle right at 1,000 RPM and leave it there. And for what it's worth, when it's at 1,000 RPM and all the electrics are off, then there's no problem whatsoever. It's when you throw all the electrics on at 1,000 RPM, that's when you get the ignition flicker light. So I think we got our lick, Mark. I think we're in good shape here.
All right, so that's it for our alternator swap from GM to Suzuki. Pretty sure it's going to work just fine. We've got a little bit of low output at idle, but it's probably enough to keep up under normal circumstances. Anyway, as you can see, it's a rather nice day out here. So we're going to go find out, I guess, if the alternator works. Anyway, thanks for watching. We'll see you next time. You do some great work.
Yeah. Kind of can't get to the steering wheel right now, but that's how it goes. Buckle up, you know.
What do you got there?
Seatbelt.
What?
Click it or ticket.